According to the National Electrical Code, specifically Articles 430.113 and 430.102, a fuse disconnect is required at the compactor location. Article 430.113 states that motors, motor circuits, and controllers shall be protected against overcurrent in accordance with this article. Article 430.102 further details the overcurrent protection requirements for motors. Subparagraph C specifies that each motor shall be protected against overcurrent by one of the following means, which includes a fuse or an inverse time circuit breaker in each ungrounded conductor. Considering that the compactor in question is a 3 horsepower, 3-phase motor operating at 208 volts, it falls under these NEC regulations. Therefore, it is necessary to install a fuse disconnect at the motor location to comply with the code. The fuse disconnect must be sized appropriately for the motor, taking into account its 3 horsepower rating, 3-phase configuration, and 208 volts operating voltage. It is not permissible to simply size the breaker in the panel accordingly and omit the fuse disconnect at the motor location. The NEC mandates the presence of a fuse disconnect at the motor itself to ensure proper overcurrent protection and safety. The purpose of a fuse disconnect is to provide a local means of disconnecting power to the motor for maintenance or in the event of a fault. It also provides overcurrent protection specifically at the motor location, which is crucial for preventing damage to the motor and associated equipment. The fuse disconnect should be readily accessible and clearly labeled to indicate its function. Its enclosure should be suitable for the environment in which it is installed, whether it's indoors or outdoors. When selecting the fuses for the disconnect, it is important to refer to the motor's nameplate and the NEC guidelines to determine the appropriate fuse size. Using fuses that are too small can result in nuisance tripping, while using fuses that are too large can compromise the motor's overcurrent protection. The disconnect switch itself should be rated for the motor's voltage and current requirements. It should also be capable of safely interrupting the motor's full load current. In addition to the fuse disconnect, the motor circuit should also be protected by a circuit breaker or fuses in the main panel. This provides backup overcurrent protection and protects the branch circuit wiring. The circuit breaker or fuses in the panel should be sized according to the NEC guidelines for motor circuits, taking into account the motor's full load current, starting current, and duty cycle. When sizing the conductors for the motor circuit, it is important to consider the motor's full load current and the voltage drop. The conductors should be large enough to carry the motor's full load current without overheating and to minimize voltage drop, which can affect the motor's performance. The NEC provides tables and guidelines for sizing conductors for motor circuits. The grounding of the motor and associated equipment is also crucial for safety. The motor frame and any non-current carrying metal parts should be properly grounded to provide a low impedance path for fault current. This helps to prevent electrical shock hazards and ensures that the overcurrent protection devices will operate properly in the event of a ground fault. The grounding conductor should be sized according to the NEC guidelines. The installation of the fuse disconnect in the motor circuit wiring should be performed by a qualified electrician who is familiar with the NEC and local electrical codes. The electrician should follow all applicable safety procedures and ensure that the installation is properly inspected and tested before being put into service. In summary, the installation of a fuse disconnect at the 3 horsepower, 3-phase 208 volts motor compactor is required by the NEC to provide overcurrent protection and ensure safety. The fuse disconnect should be sized appropriately for the motor and installed in accordance with the code. The motor circuit should also be protected by a circuit breaker or fuses in the main panel, and the conductors should be sized to carry the motor's full load current without overheating. Proper grounding is essential for preventing electrical shock hazards and ensuring that the overcurrent protection devices will operate correctly. Remember to consult the latest edition of the NEC and local electrical codes for the most up-to-date requirements. Ignoring these guidelines could lead to unsafe conditions, equipment damage, and potential code violations. Consider a scenario where the compactor motor experiences a winding fault. Without a properly sized fuse disconnect at the motor location, the overcurrent protection in the main panel might not react quickly enough to prevent significant damage to the motor. The high fault current could cause the motor windings to overheat and potentially melt, leading to costly repairs or replacement. Additionally, the fault current could propagate back through the electrical system, potentially damaging other equipment and creating a fire hazard. However, with a fuse disconnect installed at the motor location, the fuses would quickly blow in response to the overcurrent, isolating the motor from the power supply and preventing further damage. The fuses are specifically sized to protect the motor against overcurrent conditions, providing a faster and more localized response than the overcurrent protection in the main panel alone. This localized protection is particularly important for motors because they are often subjected to demanding operating conditions and are more susceptible to faults than other types of electrical equipment. Furthermore, the fuse disconnect provides a convenient means of disconnecting power to the motor for maintenance or repair purposes. This allows electricians and maintenance personnel to safely work on the motor without having to shut down the entire branch circuit or panel. The disconnect switch provides a visible indication that the power is off, and it can be locked out to prevent accidental energization while work is being performed. The NEC requirement for a fuse disconnect at the motor location is based on years of experience and research, which have demonstrated the importance of localized overcurrent protection for motors. The code is designed to protect people and property from electrical hazards, and it is essential to comply with its provisions to ensure a safe and reliable electrical system. When selecting a fuse disconnect for the motor, it is important to consider the following factors. Firstly, the motor's full load current. The disconnect switch and fuses must be rated to handle the motor's full load current without overheating. Secondly, the motor's starting current. Motors draw a much higher current during startup than during normal operation. The fuses must be able to withstand this inrush current without blowing. Thirdly, the motor's voltage rating. The disconnect switch must be rated for the motor's voltage. Fourthly, the environmental conditions. The disconnect enclosure must be suitable for the environment in which it will be installed. Fifthly, the interrupting rating. The disconnect switch must be able to safely interrupt the maximum fault current that could occur at the motor location. Sixthly, the listing and labeling. The disconnect switch and fuses must be listed and labeled by a recognized testing laboratory, such as underwriters' laboratories, to ensure that they meet safety standards. It is also important to consult with a qualified electrician to determine the appropriate fuse disconnect for the specific motor and application. The electrician can help to ensure that the disconnect is properly sized, installed, and grounded, and that it complies with all applicable codes and regulations. In addition to the NEC, there may be local electrical codes and regulations that also apply to the installation of motor circuits. It is important to be familiar with these local requirements and comply with them. Failure to comply with the NEC and local electrical codes can result in fines, penalties, and potential liability in the event of an accident. Therefore, it is always best to err on the side of caution and to ensure that all electrical work is performed by a qualified electrician who is familiar with the applicable codes and regulations. The requirements of the NEC may change over time as new technologies and safety practices emerge. It is important to stay up to date on the latest changes to the code and to ensure that all electrical work is performed in accordance with the current requirements. The NEC is typically updated every 3 years, and it is the responsibility of electrical professionals to stay informed of these changes. There are several ways to stay up to date on the NEC, including firstly, attending training courses and seminars. Secondly, subscribing to industry publications. Thirdly, joining professional organizations. Fourthly, consulting with electrical inspectors. By staying informed of the latest changes to the NEC, electrical professionals can ensure that they are providing the safest and most reliable electrical installations possible. In the context of the 3 horsepower compactor motor, the fuse disconnect serves as a critical safety component that protects the motor, the electrical system, and the people who operate and maintain the equipment. It is not simply a matter of convenience or cost savings to omit the fuse disconnect. It is a matter of complying with the NEC and ensuring a safe and reliable electrical installation. Therefore, it is essential to install a properly sized and rated fuse disconnect at the motor location in accordance with the NEC and local electrical codes. Ignoring this requirement could have serious consequences.